Alright folks, this is section 3.7. This is page 15 of your chapter 3 notes. This is a fairly short section, so we're going to take care of it all today. It tells you that we're doing the slopes of parallel and perpendicular lines. Now right off the bat it tells you that if you're going to figure out if lines are parallel or perpendicular, you're going to compare the slopes of the lines. And then the follow-up comment that the slopes of parallel lines are equal. Or you could put the word congruent there. And that makes sense because if lines are going to be parallel, they're going to be climbing at the same rate, or they're going to be falling at the same rate. That's the only way that can really happen. Perpendicular is a little trickier. It's got two blank lines here because it's got two important parts, and you need to have both parts to be perpendicular. They are negative reciprocals. Right, so what does negative reciprocals mean? We'll have a couple examples. If you have a line with a slope of 2 over 5, something perpendicular to it is going to have a slope of negative 5 over 2. You see the word reciprocal means flipping the fraction, and 2 over 5 becomes 5 over 2. And negative is, the reason why that word's there is because you have to have different slopes. And I really think that the term opposite reciprocals is actually better, because the signs have to be opposite of each other. But the vast majority of math books use the word negative reciprocals, so we'll use that here. And another example there is if you have a line that has a slope of 8, its negative reciprocal is going to have a slope of negative 1 over 8. You remember how 8 can really be written as 8 over 1, so we're going to flip it, it becomes 1 over 8, and change the signs. All right, we'll see how this goes in example 1 here. It tells you that line A passes through those 2 points, B passes through those 2. Are those two lines parallel, perpendicular, or neither? Well, it says right up above here we better compare the slopes. So I'm going to have the slope formula, but I'm going to put a little a there because we're going to have two different slopes we're going to be comparing. We want to be able to keep them separate of each other. So we're going to use that little slope formula that you learned in Algebra 1 or pre-algebra. That's the formula where you're subtracting the two y coordinates on the top and subtracting the two x coordinates on the bottom. And so make sure you're pulling the right numbers from the right spots here, because we have 4 different points here and 8 different numbers. We're talking about line A, so we're dealing with these 2 points, and we want to subtract the y coordinates. So there's 13 and 1, so I'll put 13 minus the 1. And since I decided to subtract in this order, I need to do that again. So it needs to be 7 minus the 3 in the denominator. And you could have put 1 minus 13 on the top, just as long as you had 3 minus 7 on the bottom to match up with it. And then we're just going to calculate here. You get 12 over 4, so we have a slope of 3 for our first line. Now that's not enough to answer our question because we have no idea what line B is doing over here and how that compares to a slope of 3. So we did need to do that process again for line B. So now we have m sub b for a slope of line B using the same formula. And now we're going to plug stuff in. So we need the y coordinates for B, so that is the negative 4 and the negative 3. So negative 4 minus negative 3. We're going to put parentheses there because we have back-to-back negatives. That one subtraction is coming from the formula, and this other negative is coming from the fact that the 3 is negative. And now we're going to subtract the x's in the bottom and in the same direction. So the x's need to be 6 minus the 9, and we'll calculate. So back-to-back to negatives become a positive. This is really negative 4 plus 3, which gives you negative 1. And on the bottom, 6 minus 9 gives you negative 3. And we're not going to have negative 1 over negative 3. Negative divided by negative is really a positive. So this we're talking about a slope of 1/3 here. And now we need to compare them to answer the question. We've done all the work. Now we need to just finish it off. Well, 3 and 1 over 3 are definitely not the same number. So there's no way we could say parallel, because they have to be perfectly matched for that. Perpendicular, they have to be reciprocals, and they have to be negative reciprocals as well. They are definitely reciprocals of each other. This is 3 over 1, that's 1 over 3. But they also have to be negative reciprocals, and these are not negative reciprocals because they're both positive. These are two climbing lines, they're never going to be perpendicular. So if we just got rid of perpendicular, our answer here is neither. So line A and line B are just regular old plain intersecting lines. Not parallel, not perpendicular. Flipping the page, top of page 16. There's a practice problem for you to do with line C and line D, the exact same kind of question, just different numbers. So once you pause the video here and answer, are those two lines parallel, perpendicular, or neither? Alright, so just like the last time, just like example 1, we're going to be comparing the slopes. Slope of line C, we need y's on top. The x's need to be subtracted on the bottom. So here we go. The y-coordinates are 1 and 0, so we have 1 minus 0 on the top, and the x-coordinates are negative 6 and negative 8, so we have negative 6 minus negative 8. You subtract on the top, you get 1. You back-to-back negatives here, so it's negative 6 plus 8 gives you a positive 2. So line C has a slope of 1/2. We'll see how that compares to line D. And for the coordinates for line D, so we're dealing with 1, 20 and 3, 21. The y-coordinates are 21 and 20, so I'll have 21 minus 20. And the x-coordinates in the same direction are 3 minus the 1. 3 minus 1. Then we'll subtract. We have 1 on top and a 2 on the bottom, so line D has a slope of 1/2. Line C has a slope of 1/2. Well, since they match perfectly, these lines are going to be parallel to each other. If they were to be perpendicular and you had 1 over 2, this would have to be negative 2 over 1 for you to say perpendicular, but that's not the case here. Example 2, same kind of question but written in a different form. I want you to label each one of these lines as parallel, perpendicular, or neither to our original line of that y equals 3x minus 5. So we're comparing all 6 of these to that line. Alright, first you have to figure out what was the slope of our original line. The slope of our original line right there is 3. It's in slope-intercept form. You can look right at it and pick out the slope. So we have a slope of 3. We're comparing everything to 3. Right, the first one. In fact, why don't we treat this like a practice problem? You pause the video for a couple minutes and give us 6 answers. So for each one of these, you're going to say parallel, perpendicular, or neither. Alright, so we're back here. We're comparing slopes. This has a slope of negative 3. That has a slope of a positive 3. Well, those are not equal, so we can't say parallel. But we can't answer perpendicular either because they're not reciprocals of each other. So this must be a plain old neither. These are just ordinary intersecting lines. The slope of this line is 3. The slope of that line is 3. So these are parallel. Moving right along here, we have comparing this and that. This has a slope of negative 1 over 3. That's a slope of positive 3 over 1. So those are negative reciprocals. They're opposite signs and they're reciprocals of each other. So these are perpendicular lines, this line and that line. Right, let's skip that one for 1 second here. We'll go to the next one. This has a slope of 1 over 3. That has 3 over 1. They're not opposite signs, so they can't be perpendicular, and they're not perfectly equal, so they can't say parallel. So this is another neither answer. And the last one before we go back to that, you have negative 1/3 as your slope, and you're adding a gigantic number here at the end. This number here is the y-intercept, and you notice we've not talked about the y-intercept for any of these lines because it makes no difference when you're trying to figure out are they parallel, perpendicular, or neither. We're just using the slope. So you have a slope of 3, a slope of negative 1/3, and just like this one here, this line has a slope of negative 1/3. This has a slope of negative 1/3. So these are going to be perpendicular to each other. And for the last one, you have to be careful here before you answer this last one because this is not written in slope-intercept form. All the rest of them are. So to be able to compare slopes, you've got to rearrange this so it is in slope-intercept form, and that one of the things you have to do is get y by itself. So you want to add 3x to both sides. So this becomes y is equal to 3x plus 6. And now you get to compare the slopes. That's a slope of 3, that's a slope of 3. So this is, these two lines are parallel. Right? So you have to be tricky before you go to compare slopes. You have to make sure that you're looking at the slope and not just some number. You got to rearrange it so it's in slope-intercept form. Example 3 wants you to write an equation on a line that's going to be parallel to the original line, but also run through 4, 9. So you have two different things going on here. We're going to use this to figure out the slope because if it's going to be parallel to this, they have to have the same slope. So this has a slope of 2. So we want to have a slope of 2 for our line that we're writing. It also has to go through the point of 4, 9. So here we have our slope, and there we have a point. Well, if you see point and slope, you think, well, that must be point-slope form. So you start with that form of a line and plug in what you know. So the slope's got to be 2, so we're going to put that there. And then the line the point 4, 9 needs to be put in for x of 1 and y sub 1. X of 1 goes over here, so it becomes negative 4. It looks like it's negative because that negative comes from the formula. And the 9 goes in for y sub 1 over here. And again, that's going to end up looking like it's negative because of the formula, not because of the sign over here. Alright, so this is an equation of a line. It's going to be parallel to the original one because they both have a slope at 2. And we know it's going to run through 4, 9 because we just plug those in for x of 1 and y sub 1. There's no need to rearrange this because all these said is write the equation of a line, and this is the equation of a line. It does not say put that equation into slope-intercept form or standard form, so we do not have to go any further. This is our final answer. For the practice problem, it says write an equation line that's perpendicular to that, but it runs through negative 6, 11. So it's going to be very similar to this, but keep in mind that they're looking for perpendicular, not parallel. So pause the video for a few seconds, figure out what you want your slope to be, plug it into point-slope form, and that'll be your answer. Alright, so first thing we do is figure out our slope. The old slope, so I'll put the word old there, the M for slope, old for old, is going to be the negative 1/3. But we don't want that. We want something perpendicular to that, so the new slope that we're interested in has to be negative reciprocals to that. So if this is negative, our new slope is going to be positive. And if it's 1 over 3, our new slope is going to be 3 over 1, which is the same as saying 3. So we want our new slope to be 3. Now that we know our slope, and we know it has to go through that point, we're thinking point-slope form of a line here. We're going to plug in the correct slope, the new one. And now we're going to plug in the coordinates to make sure it runs through that particular point. So the y-coordinate is 11, so it goes over here. And the x-coordinate is negative 6, so this becomes minus negative 6. One negative coming from the formula, one negative coming from the fact that 6 is negative. So we definitely want to rewrite that because we don't want to have back-to-back negatives. It's a little bit sloppy. So that becomes x plus 6, and there you go. That's the equation of a line. It's going to be perpendicular to the original line, but guaranteed to go through negative 6, 11. To finish it off here, we're talking about some ideas about horizontal and vertical lines. All horizontal lines are parallel. Right, that makes sense. You picture horizontal lines in your mind, they're all going to be parallel to each other. And just a very similar way, all the vertical lines are going to be parallel to each other as well. And then the last sentence there, every horizontal line is blank compared to every vertical line. Well, horizontal is going this way, the vertical is going that way. They have to be perfectly perpendicular. Alright, based on those ideas, we're going to answer example 4 here real quick. It says write an equation line is going to be parallel and one that's going to be perpendicular to that particular line. So one that's parallel and one that's perpendicular to that. If it's parallel to that, it's going to be they're going to have the same slopes. So x equals 3, that is a vertical line, which means we need the slope of another vertical line. Any vertical line whatsoever is going to be parallel to that. So we could have x equals 1. X equals 12, x equals negative 2, x equals 1,000,000, whatever you like. Perpendicular. Well, if this is vertical, and it talks about the vertical lines being perpendicular to horizontal lines, we need to write an equation of a horizontal line. Well, the horizontal lines are all, as you remember, y equals a number. So we need just y equals anything. Y is equal to 3, y is equal to 9, y is equal to negative 6, y is equal to 1/2, y is equal to 0.2, whatever you like. Right, that takes care of section 3.7. As you can see here, it also takes care of chapter 3, so which means we are right around the bend from a chapter 3 test. So we will talk to you later.